Alright guys, welcome to lesson 10.1, Binomial Expansions. Let's go ahead and we'll get started. So today's goal is basically to learn how to simplify expressions like this one below. There is a rule for it. Now this probably looks like a horrible nightmare to you. Now if you were in class, it might make some sense. We kind of explored this a little bit in class together, and we saw that whenever you multiply x plus b to some power n, the result always comes out with an x in the front with that same power. And as we continue down the line, that power goes down by 1 each time. So as you can see, it's n minus 2, and so on and so forth until the x is just a power of 1, and then it's gone. And the b's do the same thing, but in the opposite direction. It starts with an n, then it goes n minus 1, and so on and so forth until it's 2, 1, and then none. And then the tricky part about all this is the coefficients. And we talked in class about how that's basically just a combination of your exponent with whatever degree your x is at. So the first exponent was n. You do a combination of that with the exponent of the x term you're at, and that will tell you what the coefficient will be. Alright, so let's go ahead and apply this to an example. So go ahead and write this one down, and let's give it a shot. Alright, so the first thing I see here is that it's to the 5th power. Now it's going to be starting with an x to the 5th power. Now leave a little bit of space between each of these because we're going to be adding more stuff as we go. The next one's going to be, of course, an x to the 4th power, then 3rd, then 2nd, then 1st, and then no power at all. We're going to leave a blank there because we are going to be doing the same thing now with the 3, but going in the opposite direction. So the second term will start back here as 3 to the 5th power, and then 3 to the 4th power, 3 to the 3rd, 3 to the 2nd, 3 to the 1st power, and then no 3 at all. Okay, so as you can see, we have 1, 2, 3, 4, 5, 6 outcomes from all of this. And it will always be like that. The number of terms will always end up being one more than the original exponent. Another observation that we made when we were in class together was each term always has a degree of 5. This is a degree of 5. This whole term has a degree of 5 because 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. And then 1 plus 4 is 5. And then 5. So just some patterns that we observed in class. Now we spent a long time trying to figure out how do you get these terms here? How do you get the coefficients on these terms? Well, it's a combination of the original exponent, which is 5, and whatever degree is on your leading term here, so the x, so that'd be 4. So we have to do a combination of 5 and 4. That will give us the coefficient of this term. On this one, it'll be 5 and 3. On the next one, it will be 5 and 2. On the last one, it will be a combination of 5 and 1. And we won't even bother with the final one because it would be 5 and 0, which is just going to be 1. So you don't bother with the first or the last. Those will always just be 1. 5 and 5 would be 1, and 5 and 0 would be 1. So we don't even really worry about it. So, okay, now we're going to figure out what these exponents are using a calculator. Not exponents, I'm sorry. The coefficients using a calculator. I will show you how to do it once by hand, but the remainder of the time I'm going to be using a calculator. So if you do a combination of 5 and 4, that means you're choosing 4 objects out of 5. So that would be, we have 5 options for the first choice, 4 for the second, 3 for the third, 2 for the fourth. In combinations, order is irrelevant, so we're going to divide it by how many ways you can arrange 4 things. and 4, 3, 2 cancels out 4, 3, 2, and 1 divides into 5 just 5 times, and so the outcome will be 5. Now, for the remainder of the time, I'm just going to be using a calculator to get these answers and recording my results as I go, and you can be doing the same. So a combination of 5 and 3 will be 10. And then on my calculator, I'll do a combination of 5 with 2, and that's 10. Combination of 5 and 1 will be 5. Alright. So, what I'm going to do is I'm going to go ahead and just erase these combination symbols here. And in their place, I'm going to put those numbers that I just calculated, which are 5, 10, 10, and 5. Okay. Well, we've got everything we need. The first step of getting the exponents was pretty easy, and then we did the combinations to get these coefficients 5, 10, 10, 5. Now we just have to do a little bit of multiplication to simplify our final results. The first term is as is, nothing new there. Now we need to multiply this 5 with this 3 so that this term is in most simplified form. That would be 15x to the 4th plus, now this one's a little bit tricky, this 3 squared here is a 9, so 9 times 10 will be 90 plus 3 to the 3rd power is 27, so multiplied that with 10 would be 270x to the 2nd. And then finally we have 3 to the 4th, which is 81, multiplied with 5, 405 I believe, plus 3 to the 5th, we're looking at 243. Okay, so that is what our polynomial will be if we did a binomial expansion of x plus 3 to the 5th power. And we are now officially done with that problem. So here is an example problem for you. You can try that one. Go ahead and pause the video and give it a shot. Okay. Well, gonna have to write tiny here. They get big. So we start off with x to the 7th plus, okay. Now we're going to do a combination here of 7 and 6. That's your second term. And a combination of 7 with 5, because our third term will be x to the 5th. Okay, wow. So we're going to have some pretty big numbers here. Okay, so I went ahead and calculated all those. So let's see. The combination of 7 and 6 there would be 7. And then 5 to the 1st power is obviously just 5. The combination of 7 and 5 gives 21. And 5 squared is 25. And then the combination of 7 with 4 is 35. and 5 to the third is 125. Now, I want you guys to notice something interesting here. You notice how the coefficients here are the same on the left and right? It's always symmetrical like that. So once you've done the first half of the polynomial, you could pretty much just mirror it on the right, don't even bother calculating it, because it should come out to be the same. So, combination of 7 and 3, of course, comes out to be 35. And then to the fourth power, 625. Combination of 7 and 2 is 21, and 5 to the fifth is 3,125. Combination of 7 and 1 is 7. 5 to the sixth is 15,625, and then I squished in here at the very back 5 to the seventh power, which is 78,125. Big numbers. Alright, we're not quite done yet. We have to actually multiply these. Everything here I'm connecting with a little u needs to be multiplied to simplify the term. So these numbers are going to be really big. Let's go ahead and do that. Okay, so as you can see, there's our final result. 7 times 5 is 35. 21 times 25 is 525. 35 times 125 is 4,375. And you can check the rest here. Okay? And that is our final result. So these are pretty big. And you might think, well, what's the benefit of doing this as opposed to just using the distribution method, using foiling or whatnot? Well, you could try foiling, but I think you'd find that this is, even though it's long, it actually is faster. So let's go ahead and we'll move on to our next part.